Child is born, her grandparents decide to put $500 in an account that earns interest. They do not plan to make any other deposits or withdrawals for 18 years. When the child turns 18 years old, the money in the account will be a birthday gift. The grandfather is choosing between two options. Which option will result in a better birthday gift? And explain your reasoning. I mentioned in lesson 19, which was only Monday, not that long ago. Try to think back to that time. That you would have a problem just like the one from that lesson, and here it is. So when you read each option, decide whether it's exponential or not. And then if it's not exponential, we've only talked about one other kind of function, so try to keep that in mind. So option 1 says an account that grows by $100 each year. If it's hard for you to figure out how it's growing, like linear or exponential, consider making a table, if that helps you. So like 0 years would be what it started with. You could put in some values. So what is this account starting with? Reread it if you need to, but what is the account initial amount? Okay, so if option 1 is increasing by $100 each year, how much will it have after 1 year? It's not, so it's just option 1, 100 each year. So 600. After 2 years, how much will it have? After 3 years, how much will it have? So it's adding 100 each year. So it's adding each time. That's the difference each time. When it's adding each time, what type of function is it? I hear some people whispering it. If you're whispering y equals mx plus b, then you're right. All right, if we are adding each time to get to the next y value, then it is linear. It'll be a straight line if you were to graph it. So knowing that, in our linear functions, what's usually replaced with numbers? So here's y equals mx plus b, what usually is replaced with numbers. M and b. In our linear functions, m is for slope or rate of change. So what is it changing by each time? For option 1, it's changing by 100 each time. And it's adding 100, so it's going to be a positive 100x plus y-intercept is usually your what? Y-intercept is usually your from a real world situation, slope is rate of change, y-intercept is your so rate of change and slope are what the 100 is. The y-intercept from the situation is always your starting amount. Okay, so there was that. There was also, remember I told you whenever x is 0, that's your starting amount. So what is my starting amount for option 1? Okay, so here's my equation for option 1. This could be you showing your work, right? You're explaining your reasoning. This is option 1. To find out how much it gives me after 18 years, where do I need to plug in the 18? We have 2 options, y or x. Into the x is where we plug in the time. So I'll put this in the calculator shortly, maybe not right this second, but that'll tell me how much option 1 gives me after 18 years, the 18th birthday coming. So then option 2, when we read that one, it's an account that grows by 8% each year. I'm not even gonna make a table because it's a percent change. So I know that it should follow the format of our exponential function. But if it says something like it's doubling each year, it's tripling each year, then hopefully you still remember how to do those types of problems. But since it's growing by a percent change each year, I will use that as one. So A stands for what in our exponential functions? Initial amount, which is what? Reread it if you have to. 500. Okay, they didn't say that one account is starting with this much and the other account starting with that much. They both are starting with 500. And then it's gonna be, because it's exponential, it's a percent change, 1 plus because it's increasing. And then it's gonna be plus R, so our rate as a percentage, or sorry, as a decimal. So what is 8% as a decimal? If you don't know, divided by 100%. 0.08 works, not 0.8 because that would be 80%, so 0.08, and then to the x power or to the t power, whatever letter you want to use, that's time. X is usually time. How long is it sitting in the account? 18 years. So now I have two things that I'm going to plug into my calculator so that I could compare the values. But the better birthday gift would be the one with more money, so. Those of you that haven't done your constructed response yet, this is a free answer because it's part of the problem. But 100 times 18, that's 100. That's what option 1 is worth. That's my linear function. And now when we do our exponential, of course, it won't tell you if it's exponential or if it's exponential. You have to figure that out. And you use equations for both. This one is worth 1,998.01. Now, which one is the better birthday gift? Option 1 or option 2? Option 1. And you could say you can have all this work shown, and that could be your reasoning. But otherwise, like, don't, I mean, obviously pick one, even if you don't know what's going on, pick one of them. But, reasoning is part of it, so you will see either work shown or an explanation. Option 1 is linear, so it's kind of surprising that it was still worth more. But know that eventually they both will exceed, the exponential function will exceed the other. If you're really, really not sure, maybe lean more towards the exponential function, but the only way to know for sure is to plug them in and compare. I guess on the linear function. All right, other questions from either parts of the study guide? Shy. Struggled with it today, and you struggle with it when you take the test, and you should do that.